Let's be honest, we are all swimming in an ocean of data. Just think about it. Your phone contacts, your shopping history, your social media feed, it's everywhere, all the time. Now scale that up. Imagine you're a big university with thousands of students. How in the world do you keep track of everything without it turning into complete chaos? Well, today, that's exactly what we're going to explore. The journey from data chaos to crystal clarity. And we'll see how one hero makes it all possible. The database.
Right, so to really appreciate why the solution is so brilliant, we first need to get a feel for the problem itself. Let's stick with our university example. We've got thousands of students, hundreds of courses, and a whole bunch of different departments. It is the perfect place to see what goes wrong when your data is a total mess. So, let me paint you a picture. Imagine you're a student. You pop over to the registrar's office and you update your home address. Simple enough. But then a week later, you get a bill from the accounting department, and it's sent to your old address. Wait, what? How does that even happen? Why is your information right in one place, but totally wrong in another? This is the exact problem we're about to unpack.
And here's why it happens. This is the old way of doing things. Before databases became the norm, every department was basically its own little island of information. The registrar had its own set of files, accounting had theirs, athletics had theirs, and none of them were connected. This creates what we call data silos, these isolated pockets of information that just can't talk to each other. Honestly, it's a recipe for disaster.
So how do we fix this gigantic mess? Well, the answer is a whole new way of thinking called the database approach. And the engine that powers this approach is a really clever piece of software called a database management system, or DBMS for short. Think of it as the new central brain for our entire university's data.
And bam, here is the after picture. See the difference? It's huge. Instead of all those separate, messy files, all the departments are now connected to one central database management system. They all put information into it, and they all pull information from it. This creates what's called a single source of truth. You update your address once, and everyone, literally everyone, gets the correct information instantly. It's clean, it's simple, and it's so much more efficient.
Okay, so a DBMS really has two main jobs. The first one is to go to war with all the problems caused by that scattered data we saw earlier. It's specifically designed to hunt down and minimize three of the most common, most frustrating data headaches out there.
The first enemy is something called data redundancy. Put simply, it just means you're storing the exact same piece of information in more than one place. It's like having 3 different entries in your phone for the same friend. It's not just wasteful, it's actively asking for trouble.
Let's jump back to our university. In the old system, a student's address isn't just stored once. Nope. It's in the registrar's files, it's copied over into the accounting files, and then it's typed in again in the athletics department's files. That's 3 copies of the very same data. So what happens when the student moves? Someone has to remember to update it in all 3 places. And if they miss just one, you've got a problem.
The second problem to tackle is data isolation. Whenever a department keeps its data locked away in its own private files, often in totally different formats, sharing that data becomes a complete nightmare. The information is basically trapped, or isolated, inside its own little digital jail cell. You see this all the time with employee data. The payroll department needs to know your salary to, well, pay you. The human resources department, or HR, also needs your salary info for things like performance reviews. But if that data is stuck in 2 separate, isolated systems, they can't easily see each other's files. So what happens? You end up entering the data twice, which, of course, brings us right back to the first problem of redundancy. See how it's all connected? And all of this leads us directly to the third and final problem, data inconsistency. This is what happens, almost guaranteed, when you have redundant, isolated data. You've got multiple copies of the same information floating around, so it's only a matter of time before they stop matching up. Imagine an employee gets a well-deserved raise. The HR system that's updated right away with the new salary. Fantastic. But what if someone forgets to update the totally separate payroll system? Now you have 2 different salaries for the same person. So which one is the truth? This kind of inconsistency can cause huge problems, from people getting paid the wrong amount to the company's financial reports being completely off. You just can't trust the data anymore. So we've seen how a DBMS is like a super cleaner for your data mess. But it's not just about fixing problems. That's only half the story. It's also about unlocking potential. By bringing all that data into one place, a DBMS maximizes three incredible benefits. It basically gives your information superpowers it never had before. First and foremost is data security. Think about it. When all your most valuable data is in one central vault, it's so much easier to protect. Instead of trying to put locks on 50 different file cabinets all over the building, you can focus all your security efforts on that one central database. A fantastic feature of a good DBMS is that you can set very specific rules. For example, you can create a rule that says only authorized people from the HR department are allowed to see sensitive data, like employee salaries. If a professor or a student tries to peek at that information, the system just says, access denied. This is called role-based access, and it's an incredibly powerful way to keep data safe. Next up, a DBMS maximizes something called data integrity. Now, this is a little different from security. Security is about who can see the data. Integrity is about making sure the data itself is accurate and reliable. It's about enforcing rules to make sure the data always makes sense. For instance, you can program a simple rule into the database that says the age field for any student has to be a positive number. Sounds obvious, right? But now, if someone accidentally tries to type in -21 for a student's age, the database will just reject it. It won't even let that bad data in. These little rules are crucial for keeping the overall quality of your information high. And the third benefit is a little more on the technical side, but trust me, it's a real game changer. Data independence. All this means is that the data itself and the computer programs that use the data are not locked together. They're separate, they're independent from each other. So why is that such a big deal? Well, because of data independence, the university's IT team can build a brand new app for your phone to help you register for courses. That app talks to the database, but it isn't permanently glued to it. Later on, if they want to completely change the app's design or add new features, they can do that without having to rebuild the entire student database from scratch. It makes everything so much more flexible and faster to develop. All right, so we've pretty much covered the why databases are so essential for making sense of information. Now, let's take a quick peek under the hood at the how. How is all this data actually structured and organized inside that amazing central system? It's all built up in a very logical way, kind of like building with blocks. Let's go through it step by step. At the very, very bottom, you have a bit, just a single 0 or 1. You group 8 of those bits together, you get a byte, which is enough to represent one character, like the letter A. A group of related characters makes up a field, like a student name. Then you combine all the fields for one student, their name, their age, their major, and you get a record. Think of it as one row of information. A collection of all the student records forms a file, but in database language, we usually call this a table. And finally, you bring all your related tables together, the student table, the course table, the professor table, and that entire collection makes up the database. Now, the most popular way to organize these tables is called the relational model, and its secret weapon is using special keys to connect everything. Take a look at our student table here. That roll no column is what we call the primary key. You can think of it as a unique ID for each student. Like a fingerprint, no two students can have the same roll number. This is how the database can find one specific record in a flash. Now look at the course ID column. This is a foreign key. It's doing something different. It doesn't identify the student, it points to a record in a totally separate course table. This little key is how the database knows that both John and Aisha are taking course CSC 101. It's a brilliantly simple and powerful way to link data together without having to repeat it everywhere. So we've seen how databases take us from total chaos to beautifully organized data and neat, connected tables. Our modern world absolutely runs on this stuff. But here's a final thought to leave you with. What happens when our databases evolve? What happens when they stop just storing data and start to truly understand the complex web of relationships between all that data? This, my friends, is the next big step, a step that promises to make our information not just organized, but genuinely intelligent. Thanks so much for joining me today.